Awesome. How's everyone? Awesome. Cool. Hey everyone. So I am Ashwin, and I'm going to talk about large-scale exposure of secrets, sensitive information over on different Git platforms. I'll come to a point where I'll explain why different Git platforms and not just Git. Cool. Bit of me. I work with Relevant Labs, where I lead research and consulting. I dabble in web, cloud, supply chain security, and I have been a speaker and trainer for different conferences like Black Hat, ZeefCon, and now Nullcon as well. And here are my socials. Feel free to follow me, I guess. So what's on the menu? So we'll first cover what are dangling commits, and why are we even talking about it? What's the security risks? And to analyze the impact, we will talk about what is the, based on the large scale study that we have done, what's the true impact of this study. Yeah. Cool. I hope everyone knows about Git, right? So Git is a decentralized version control system where developers can collab together on a project and they have a local copy of their own. And commit is just an activity to write to these repo. Thank you so much. Cool. A few questions now. How many of you have used Git? Can I have show of hands, please? Awesome. Lots of you. Nice. How many of you made Git, commits to a Git repository? Nice. Keep your hands up. Keep your hands up. I have a few more questions. How many of you have memorized the Git commands and not know what does it mean? Awesome. And how many of you have pushed sensitive data to Git repository? Thank you for the truth, guys. Exactly right. So all of us have at some point of time pushed something. Not me, obviously, because I know about this. Cool. So how do we delete these commits, right? The general consensus is git reset and go back to the previous thing, and you will not see what the commit is, right? So what if I told you these deleted commits does not disappear? They exist in the Git ecosystem. You don't have to believe me. Take a look at it. So over here, what's happening is, what I have done is committed a secret file in the Git and with an obvious name, and I'll just push it to GitHub. Now, what is happening is, if you can see over on the GitHub side, you can see there are two different commits. I have just opened the commit in a different tab for further references. And now what's going to happen is, I'll just git reset it. And as everyone says that, perform a git reset and you're good to go. But what is happening is, you remember, right, the commit that I have opened separately in the GitHub side of things will go in that, and over here you can see the commit is gone. You cannot see the commit anymore. And when you go to this side of things, you see a big yellow banner with things like that you have abandoned me. It's sad, guys. So now, how many of you think git reset works in the way we thought it used to, right? So that brings us to the concept of dangling commits. So dangling commits exist in the repository, but they are not connected to any branches, or it is part of the repository, but you cannot directly correlate it. And this is how dangling commits look across different platforms, on GitHub, GitLab, Bitbucket, and even on Git. It's more or less the same. It's a thing that Git does, and it's the responsibility of the Git platforms to manage them. So, if it is a thing that Git does, why is this an issue? So, when do you remove a commit? Maybe you don't want it in the Git history. Maybe you have made a mistake. Maybe you are just cleaning up things. Or maybe you are trying to hide something. But Git, as you all know, does not forget things. So it have some level of some data that you have pushed to a public repository. So over there, you can see there are just, I don't know if you can see that, but secrets, production secrets that are pushed on env.prod on GitHub, and similarly, they are being removed. So we reached out to these Git platforms about the issue, and like on Git level, there's a way to deal with dangling commit on the local level, but it becomes a bit difficult when we are talking about the Git platforms as a whole. Now, they said that they have no plans to fix it, but shared a guidance for manual removal, right? So we have a solution, and we did git filter repo and remove the data that is already present. And same used for like BFG cleaner can also be used for the same. Now, how many of you think that the commit is still there? One. And only one person gets the prize. Commit is still there. Even after running the git filter repo, it is still there. You can see the the yellow banner on top of it, even after you have run the git filter repo. So yeah, we cannot do anything. Thank you for attending my presentation. Thank you everyone for coming. But jokes apart, so how do we actually remove the dangling commits? What GitHub says is, if you want to remove the dangling commit, just hit us up. We'll do it. And just, you get scene zoned. You get, it takes a bit of time for them to work on. So submit a request and hope for the best. You can delete the repository if that's your thing. Sure. Or you can make the repository private. But like, if the commits are not there, like if you can't find it, then there is no impact, right? You cannot do anything with these commits. Let me tell you a secret. We were able to enumerate these dangling commits using the events API. Now, before we move forward, let's see why we chose GitHub for this. So, in our research, so we have a research dashboard where we map all the different commit events, commits that are there, and based off that data, there are 34 million commits every single month on GitHub. So it's the best place where we can go ahead and look for the secrets or any sensitive data, and there's better chances of getting those over there. For this particular research, we took around 5 years of Git commits data, and based on that, the next slides from here on will continue. So, how many of you are aware about GitHub events? What it does? Okay. So basically, there are different kinds of event that GitHub provides. Repository event, user events, public events. And based on those events, whatever you do on Git, they are gonna be registered over there. Even you commit or do anything over there, start a repo, start watching a repo, whatever you do, they are always on the GitHub events. Now, from this, how can we find out what a dangling commit is, right? So in this, generally dangling commits are forced pushes, and the commits that are there are 0. The commit count is 0. But that's not entirely true. Like, you can force push for different types of, or you can have this kind of event for different types of issues, right? Like branch deletion, tag creation, empty push, stuff like that I have mentioned over here, right? So how do we filter the noise? So what we did was we analyzed GitHub's branch commit endpoint. So branch commit endpoint is something that tells us, hey, this branch, this specific commit belongs to a specific branch. And from there, if that does not mean, if that does not give us any branch, that means it's dangling. It's pretty straightforward like that. And GitHub uses the same method internally. That yellow banner that you see does not by default comes on from the server side, but it is loaded from the JavaScript pieces. So based on that, we filter the noise. Now, missing ingredient is lots of GitHub events. Since like the GitHub only takes stores 30 days of data, we needed much more than that. We need around 1500 days of data. So we at Redundant Labs have like a historical data set of GitHub commits, and from there it became a piece of cake on doing this research. Let's talk some engineering. So we have a store, we have this data stored in Elastic. We took that data of the push events and distributed it across 20 different nodes, and all of them are doing two primary tasks. One is commit scanning, where you extract the details from what the commit is, what are the emails these things have been committed, and a secret scanning based on our internal regex patterns that we have found. And we create a JSON out of it and store it in another Elastic for further analysis. And obviously, engineering does not always cut it, so some jugaad. Basically, to monitor, I have opened multiple things in a single screen and did the monitoring part of it. So these GitHub events, pattern recognition, and at-scale engineering, these were used to do this perfect dangling commit detection. And from here, we are able to uncover the real impact of the dangling commits. So, out of 5.4 billion GitHub commits, we were able to find 66 million dangling commits after doing all the filtering and the processes that were needed to get to this number. From there, around 500,000 secrets were found, obviously verified, unverified. Some are working, some are not, but they're still there. Now the most interesting question that I found to be in the slide is, what day of the week the most number of dangling commits are made? Oh, damn. Yep. It's Friday. So around 22% of the commits are made on Friday. So Friday deployment rocks, I guess. And when they come on Monday, they think yeah, we made a boo-boo. So let's make the changes and get it over with. These are the top companies who are responsible for most of the dangling commits. We have Snyk, Naver, QQ, Checkmarks, Red Hat, 163, whole lot list. These are non-free emails, so we had to target them. But yeah, these are the ones having the most number of dangling commits. This does not mean that they have secrets in those dangling commits, but just that they are pushing a dangling commit, which by default is not a problem. Now, the second interesting thing that we have is top commit messages. For some odd reason, release 4.0.0 is pretty popular. So it's one of the top commit messages in dangling commits. ChatGPT at its rise, lots of added ChatGPT data commit messages, saving release notes and test and things like that. We found lots of different kinds of secrets, from Cloudflare API token to ChatGPT tokens, Docker Hub tokens, GitHub tokens, AWS credentials, working AWS credentials, Hugging Face, Ethernet scan, GitLab, Google Cloud. Some are working, some are not. Now the entire state of dangling commit looks something like this. From around 5.4 billion commits, 66 million are dangling commits. Around 600,000 secrets which were found. Friday is the day of the week which sees the most number of dangling commits. And there are different commit messages that we just saw, like saving release note, added ChatGPT data, release 4.0 is amazing. And with top companies that are responsible for these dangling commits. And all the different kinds of secrets that we have found during this research process. For sure, this is not an issue, right? not at all an issue. So what do we actually do to avoid creating this? You can host your own Git management systems. It provides full control over your Git platform and like commit policies, but it is also costly and complex to scale. And the bigger problem is you can control your own organization. You cannot control people who are gonna go and create their own repository and push it over there on public GitHub. You cannot control that. So based on that, and apart from that, like public repositories, different folks, and different repositories which your employees or your like individual repositories have been created, where we have found lots of data, like the secrets which can be correlated to the different companies that the secrets belong to. Apart from that, you can set up automated detection and monitoring. You can use detection logic, the research that we have done. You can create a detection around it, and you can immediately rotate the secret as soon as you are aware that this has been published. AWS and a bunch of different service providers also provide us a way that they will GitHub will if you have pushed something on GitHub, you will be notified about it. So that's one good thing. But apart from that, the funny thing is, if you are leaking GitHub tokens, GitHub does not get back to you saying, hey, you have leaked GitHub tokens. So as much as you do, there is going to be things that is not in your control. So there's the human factor or the awareness factor. Developer awareness and training is one of the most important things that they need to understand, that, hey, this is the task that this is what happens from dangling commits. If you are leaking any secrets, please let us know and we can do something about it. Encourage different security, secure commit hygiene, be it in the open source or in the enterprise projects, and enforce pre-commit hooks, signed commits, branch protection rules, etc., that these Git platforms provide. So that's all from me. For any queries, reach out to research@redentlabs.com, and you can find me over on social, and we'll take the questions offline. Thank you so much. No? Yeah, we can do a query. I thought time's up. Oh, okay. Yeah. Sure,
Hello, people. We are open for Q&A.
We are open for Q&A if there's time. And if you are leaving, there are some stickers over here. Feel free to grab them. Yeah.
Hey, amazing talk. Sorry, I missed the first few bits of it. Quick check. So GitHub does provide secret scanning abilities inbuilt. It's in-house. In fact, to my understanding, it does not cost anything, in fact.
Yeah.
Right? So can we not employ those things to, avoid these dangling commits to also showing up secrets in that?
Yeah. So you can enable GitHub's secret scanning facility on your organization. But for example, I have a company, abc.com. And I go and commit on a personal repository which is public, and I commit some secrets over there. It's not under your control.
Right.
Yeah. So in that, though there are many edge cases like that where you cannot deal with the consequences of like committing a secret into the GitHub.
All right. So I'm trying to get the crux of it, right? So is the problem with the secrets, or is this a problem with the dangling commits with the secret?
With the secret.
With the secret.
Yes.
Sorry.
Dangling commits by default are not a problem. Even Git gives that feature. But like the Git, but in Git you can handle that. You can repackage the entire Git pack, and you can deal with it in some ways. But like these Git platforms, even if you remove it from your system, you saw like Git filter repo did not work completely. So even if you remove from the system, it's not gonna get removed from the online platforms, remote platforms.
Obviously, it's because that goes with the legitimate commits also, right?
Yes.
So if you have secrets leaked in any legitimate commit, which is with a valid author tags and all, right?
Yeah.
Your secret will live in the system forever until you go and hard delete that repo.
Hard delete that repo.
Yeah, I mean, you just need to wash out. So, for example, okay, we have, for example, some check-in to a secret, right? Later point of time, we realized that, hey, we are checking in the secret.
Yeah.
The only way to completely get rid of that secret from the system is to delete the repo. Because it carries the version, right? You can still go and check the secrets in the history, right?
Definitely. So that's why, let me share this again. Yeah, so just a second, please. Yeah, if you see this, you can contact GitHub as well. They can remove that commit for you.
Yeah.
You can delete the repository.
Sure.
But not all public repository can be deleted because of the previous...
the history, it carries.
Previous history and many other things. And you can also make the repository. So there are different solutions, but none of them are foolproof.
True, to that point. Right? So I'm just trying, why I'm emphasizing on that is because dangling or not, that issue is still there.
Yes.
With the legitimate commit also, right?
But why I'm focusing on the dangling commit is something because you cannot see them on your repository.
Backtracking
so the attack complexity increases in that aspect. Yeah.
Makes sense. Thank you so much.
Any other questions?
Any other questions, folks?
Why does it say maybe here?
Sorry?
Why does it say maybe here?
That's so basically there was a research from Trufflehog, as far as I remember, where even from the deleted repositories you can get from the forks of it, you can get the data out of it. So that's why maybe.
Okay, understood. Yeah. And what kind of impact do you feel like this will have for big companies who are hosting their own secret or their own source? Self-hosted GitHub, GitLab. Yeah. So they have more control over on the commits that are being made. So when we are reaching out to GitHub, I'm assuming that you can just go ahead and control that commits on your own. So from an enterprise perspective, you have more control. You can set pre-receive hooks on your server side that just to not allow anything to get committed that contains a secret. And there are multiple different ways. So from a self-hosted perspective, it becomes a bit easier. But then there's another cost of maintenance, another cost of doing lots of other things to make sure that this specific thing happens. That's under the assumption that I know about these things and have these hooks. Because otherwise no one is going to interfere with my system.
Yeah.
Okay.
Yeah.
Thank you. That's a great question. Can you please pass on the mic?
Hi. Yeah. So I have a question in a different direction. One of the biggest pain points with secret scanning is the amount of false positives there are, even if you use Trufflehog or Git leaks or something like that. So I'm curious, how did you deal with that? Because even if you get a secret that looks legit, it might be old, it might not be active, so you never know unless you actually try it out.
Definitely. So internally we have used our own secret scanning capabilities, where we have done things like, I don't know if I can disclose a lot about it, but we have done things like blacklisting of keywords that, for example, in AWS keys, if you see example in between, we just skip that. Apart from that, we have done some level of validation. There are some health check APIs which can be used to validate if the secret is active or not. There are many such things that we have done to make sure we get less number of false positives. But obviously, if we are dealing with regex, false positives can be there. But we have tried our best to reduce the number of false positives. Yeah.
Thank you for that. That partially answered my question. So maybe to follow on from that then, so given that you checked some of these credentials, whether they were still live, did you reach out to those companies as well? Because on their end may have triggered an incident, right? Like from a strange IP address, suddenly someone checking an AWS key. Did you reach out to them?
So this research was completed a week before this. So we might reach out to them, and because responsible disclosure is something that we do at Red Ant Labs. So we might reach out to them and we'll let them know that, hey, this is working and you should fix that. So, and because in 1 week, it was just difficult for me to create a presentation, prepare the talks. So yeah, that's the thing. Yeah.
Oh, good answer. Any other questions?
Related to the previous question, have you checked if there are any companies in your data set that have bug bounties and where you could get a nice bounty from that?
So, yeah. So we might do that, yeah. Yeah.
I should probably take not more than a minute. So to answer that, there is way to, GitHub does provide the ability to check the secret validity also. So just need to configure that.
But not for all secrets.
Not for all. Of course, that problem is there, right? So there's also a way to kind of register your own secret patterns so that it will detect. Just to answer a few questions that I saw, I think it will be helpful.
Yeah. Thank you.
That's great. Any other question, folks? That seems all.
Awesome. Thank you so much, everyone.
Thank you
for
so
coming.
much, Kumar, Ashwin.